Okay, let's calculate the slope of this linear relation. We're going to use a new equation to do that, which is really the same as rise over run. But if we have points on our grid already, we can use a new equation that recalculates the slope using the coordinates of those points. So if we kind of decompose that for a second, if you think about rise is when I kind of draw that triangle in here. If I was going now, my rise is decreasing here, but from that start point down, my rise is kind of the change in the vertical parts between these 2 points. So it's the change from 80 down to 68. And the run is really the change from 0 to 100. And that's what this calculation does. The notation is saying, like, say this was point 1, then this is x1 and this is y1. And if this is point 2, then this is the x2 and this is the y2. And if this was the third point, we could call that x3 and y3, or so on. Okay, so we can calculate the slope of a line between 2 points if we know the coordinates of the points. So if I'm going to do that, I can use these as my first point and my second point and plug in these values into this formula, and that will calculate my slope for me. So y2 is 68. Plug that in for y2 there. y1 is 80. Plug that in there. x2 is 100. And x1 is 0. So notice the rise is really that, as I said, that difference between 68 and 80. And the run is that difference between 0 and 100. So now if I do this calculation, I've got 68 minus 80. So we're going to get negative 12. And then we have 100 minus 0. And that's just 100. So our calculation, notice the slope is going to be negative when we've got a decreasing line. So when I do that, I could reduce it as a fraction. Or we could calculate it into a decimal. And if we interpret it like the question asks, this is our liters as the car drives. This was the liters in the tank to start with, and this, our independent variable, is measured in kilometers and hundreds. So our slope is that rate of change, and it's liters per kilometer. So we're going to write liters per kilometer, and if we interpret it, this is as we drive, we are losing 0.12 liters every kilometer we drive. Now to do part 2. Part 2 is determine the vertical intercept. Our vertical intercept is that start value is also when x is 0, so our vertical intercept is 80. And that's our b in our kind of our equation for the third part. So our third part is to write an equation. It's linear, so we have an mx plus b equation. Now the slope is the rate of change. We've already calculated that, so our equation is going to be, I'm going to use the fraction format, so negative 3 over 25 x plus the vertical intercept, which is 80. Now we could get a little bit more nitpicky. We could use n for the number of kilometers and L for the number of liters. Let me erase that, and I'll write L and N in there instead of X and Y. So I have L is negative 3 over 25, N for the number of kilometers plus 80.